Okay, so we are going to start moving into our chemistry unit. Our essential question for today is, how do you describe physical properties of matter? So it has two learning targets, 4 and 5. Explain and apply the difference between mass and weight, and explain how density can be used to describe matter. Okay, so remember, matter is anything that has mass and takes up space. Example, air, soil, water, those are all examples of matter. Matter is made up of atoms or particles, and matter is also can be classified as elements, compounds, or mixtures. So that should be a little bit of review from our 6th grade chemistry unit. Okay, so when we talk about matter having mass, mass is something that will not change as matter is moved from one place to another, even in space. So if you go to the moon, all the matter is still there, so the mass stays the same. For example, okay, bananas that have a mass of 1 kilogram on Earth, take those same bananas and you take them to Mars, and they're going to have a mass of 1 kilogram. Take them to our moon, still going to have the same mass, 1 kilogram. So no matter where you take matter, the mass is going to stay the same. Now weight is different. Weight is actually a force. It includes mass and the pull of gravity. Weight is not constant and can change when matter is taken to places with different forces of gravity, like space. Weight, since it's considered a force, is measured in newtons. The formula for weight is equal to mass times the force of gravity. Now here on Earth, the force or acceleration due to gravity is 9.8. And so whenever we want to find our weight here on Earth, we take our mass and multiply it by 9.8. So let's take a look at this example. On Earth, this astronaut has a mass of 120 kilograms. That same astronaut goes to the moon. Notice the mass is still 120 kilograms. Okay, so notice the mass does not change as you go from Earth to the moon. Now, if you take the same person, you take its weight. Take the person's weight. On the Earth, the weight is 1,200 because we're going to take 120 and we just rounded up the 9.8 to 10. So that 9.8, which was acceleration of gravity on Earth, round that up to 10, so 120, the mass times force of gravity. 1,200 newtons is the weight of the astronaut on Earth. Go to the moon and notice you weigh less. The reason why the astronaut weighs less is because the moon is a lot smaller than the Earth. So if the moon is a lot smaller than the Earth, the moon has less mass. Therefore, it has less gravitational pull. And that's why the moon orbits Earth, because the Earth has a greater gravitational pull, so it pulled the moon into its gravity, and that's why the moon orbits us. So when you go to the moon, since the force of gravity is less, you're going to weigh less. Let's just give it a number. Let's say the acceleration due to gravity on the moon is about 2. So if you multiply 2 times 120, you're going to get 240. So that's pretty close. 240 newtons. So anytime you go to a smaller mass planet or satellite in space, you're going to weigh less. Versus if you go to Jupiter, which is a lot larger than Earth, it has a lot heavier or bigger gravitational pull. So if you go from Earth to the moon, you're going to weigh a lot more because the force of gravity on Jupiter has increased. Okay, another physical property of matter is volume. Volume is the amount of space matter takes up. Volume is measured in liters, L, that's the units. Formula, there's 2 ways for volume. If you have a regular object, you can measure the length, width, and height, and volume is measured in centimeters cubed. Remember we did a density lab in 6th grade where we had regular objects versus irregular objects? If it's an irregular object, like this person, okay, we don't have a certain length, width, and height, you have to use water displacement to find the volume of irregular objects. So how do you do that? Okay, you fill a graduated cylinder up with a certain amount of water. Okay, dump the irregular object in this case it's a little stick figure in here. The volume rises. You measure how much water is displaced. So it went from 3.4 to 5. So that's going to be 2.6 is the amount of water that's been displaced. Or sorry, 1.6 is the amount of water that's been displaced, and that's the volume. Okay, density is another physical property of matter. We've talked about density before. It's how heavy something is. The formula for density is mass divided by volume. The units for density is grams per milliliters. Grams is for mass. Milliliters is if the volume is measured using liquids. Grams per centimeters cubed would be if the volume was measured with a regular object. Water's density is always going to be 1. So if we want to look at different substances and try to figure out what they are, we can put them in water. If their density, if they sink, then that we know their density is greater than 1. If matter floats in water, we know the density is less than 1. And this is a picture showing you the atoms of matter packed tightly together. That makes something very heavy, very dense. Now over here is something you want to make sure you put in your notes, because we're going to start working with density, mass, and volume and calculating problems, math problems. So this is an easy way to remember how to solve for either mass, density, or volume when you're given one of those two variables. For example, if we cover up density, okay, and I'm just going to highlight, meaning I'm going to cover it up. Density, let me get that back on there. Density will equal mass, and then this line right here, divided by volume. So again, that's the formula for density. Now if we want to solve for mass, okay, underneath mass in this triangle we have D next to V. So that means you would take density times volume, because whenever two variables are next to each other, it means you multiply. If you want to find volume, you're going to take mass divided by density. So that triangle is a pretty handy thing to have and to memorize, so you know all the formulas to find mass, volume, and density. So we're going to go over how you would calculate density. There's 4 steps I would like you to follow. But given this example, an object has a mass of 10 grams and a volume of 2 milliliters. When you do density problems, one of the easiest things to do is to underline your mass and your volume. Underline the numbers and what it like just like I did. The mass is 10, the volume is 2 milliliters. Then the first thing you're going to do is figure out, okay, what is the question asking? Well, it's asking to calculate density, so I'm going to highlight density. So then I know the first thing, number 1, I want to know the formula. So density equals mass divided by volume. So I'm going to write the formula in so I know what to do. Then I'm going to substitute. So now I'm going to plug in my numbers to calculate density. So I'm going to plug in my mass, which is 10 grams. Plug in my volume, which is 2 milliliters. So I'm going to record those in the substitute so I know what 2 numbers I'm going to be using to divide. Then I'm going to solve. I'm going to take 10 divided by 2, which equals 5. Then I'm going to make sure my answer has my units. So remember, mass is measured in grams. The volume was measured in milliliters, so the units are grams per milliliters. And you're going to get some practice with this, with calculating density, also with calculating mass and volume. Okay, that concludes our notes on the physical properties of matter.